Section 3.6, Polynomial and Rational Inequalities. Remember what it means to be a polynomial, like a quadratic or a cubic, and what it means to be rational, which means a fraction. But we're going to have inequalities. So symbols we will be using will be a less than or greater than symbol, or a less than or equal to or greater than or equal to symbol. Remember that we use parentheses to show that we do not include that starting point or ending point. But if we have the less than or equal to symbol or the greater than or equal to symbol, we're going to use brackets to show that we do include that starting or ending point. So to graph nonlinear inequalities, the first thing we want to do is put it into the form of ax squared plus bx plus c. Normally we have an equal sign here, but we're going to have one of these inequalities in this box with a 0 on the other side. So we're going to, step 2, pretend you have an equal sign and solve the equation. Step 3, divide the number line into parts by plotting the solutions from part 2. Step 4, choose a test point. If the test point makes the original inequality true, you're going to shade where that test point is. If the test point makes the inequality false, don't forget you're going back to the original. If it makes it false, do not shade where that test point is. And then you're going to write the solution using interval notation. So we're going to do a couple of these examples together, and then you're going to try a couple on your own. So I'm going to circle number 2 and number 4 for you to try later. Number 1, x squared plus x minus 6 is less than 0. So what do? Putting it in standard form, back up here, putting in standard form, we have the 0 on the right hand side, which is perfect. Next, what do we want to do? Pretend we have an equal sign. So we're going to say x squared plus x minus 6 equals 0. And then step 2 was to solve that equation. So this one's factorable into x plus 3 and x minus 2 equaling 0. So our breaking points will be negative 3 and positive 2. So on the number line, we have 0, 1, 2, 3, and so forth. Negative 1, negative 2, negative 3, negative 4, and so forth. Breaking it up into breaking points, draw a dotted line down at negative 3 and a dotted line down at positive 2. So you can see we have 3 parts, the left side, in between, and the right side. So what test point do you think we want to try? Well, I would like to try x equaling 0. So my test point is going to be x equaling 0. And you plug that back into the original inequality. So the original equality here, we have 0 squared plus 0 minus 6 is supposed to be less than 0. We want to know if that's true or false. So we end up getting negative 6 is less than 0, which is true. So that means your 0 test point worked, so you're going to shade where the 0 test point is. Now, we would also want to try a test point to the right and to the left. So if we try another test point of, say, x equaling 3, that would be to the right of 2, we would have 3 squared plus 3 minus 6 is supposed to be less than 0. Well, 3 squared is 9, plus 3 minus 6 is definitely not less than 0. So this would be a no. The middle piece was a yes, and if we do a test point on the left-hand side, we'll see it's a no. Now, we had strictly a less than symbol, so going back to the top, with strictly less than or greater than, we use a parentheses. So we're going to have a parentheses at the negative 3 and a parentheses at the 2. Then it says to write using interval notation. So interval notation says go from left to right and show me what you shaded. So we don't shade anything till we get to negative 3, and we shade all the way to 2. So negative 3, comma 2. We use parentheses again because of the strictly less than symbol. So let's try number 3. On number 3, the first thing we want to do is make it equal to 0. That was our first step. So we're going to need to subtract over the 2. So x squared plus 3x minus 2 is greater than 0. We then pretend we have an equal sign. So we have 9x squared plus 3x minus 2 equals 0. Now this one is factorable, but if you don't want to factor doing the AC method, you could use the quadratic formula. I'm going to go ahead and jump to the factors, which is 3x minus 1 and 3x plus 2. So my breaking points would be 1/3 and negative 2/3. So on the number line, we have 0 in the middle, 1, 2, -1, -2, and we have a negative 2/3, so we'll have negative 2/3 about right there, and a positive 1/3, so 1/3 about right there. Draw a dotted line down to show our breaking points. So we have to the left, the middle, and the right again. So we'll do a test point, and the test point we'll try again will be x equaling 0. The original inequality. So we're going to have 9 parentheses 0 squared plus 3 parentheses 0 is supposed to be greater than 2. Is 0 greater than 2? No, so that is a false. So the inside piece would be a no. We could try a point on the right side or on the left side. If we try a 1, let's just plug that in. We're going to get 9 plus 3, which is 12, and 12 is greater than 2, so this would be a yes. So we're going to shade this direction. And if we go over here and try a test point, we'll shade that direction. Most of the time your shading is a skipping pattern. For example, it'll say yes, no, yes, or no, yes, no, and so forth. For the most part, that's what it does. Up here, it went no, yes, no. So again, it kind of skips every other interval. We'll use a bracket or parentheses. Well, again, we have strictly greater than, so we're going to use parentheses. On these examples over here, we have a less than or greater than equal to, greater than equal to, so you'll definitely use brackets. So writing interval notation, we're going to go from left to right and show me what we've shaded. So we're going to go from negative infinity to negative 2/3. So negative infinity to negative 2/3, union positive 1/3 to infinity, and everything has parentheses, no brackets. So I'll give you the answers to number 2, just so you can have it, and on number 4, work it out and make sure you can do them. So it would have been from -3 this direction to the left. Here's 0 in the middle. We have 4 is another breaking point, and it would have been to the right as a yes. So for interval notation, it would have been from negative infinity to -3, bracket, union bracket, 4 to infinity. For number 4, I'll start you off by making it equal to 0. This one you can divide by -1 if you want to make your signs change. And then we could factor out a GCF. So we have x times x minus 4 equaling 0. So our breaking points would be 0 and 4. So we have a breaking point of 0 and a breaking point at 4. I'll let you finish that one and decide where the shading should be. So on to the next page. Number 5 is, like I said, there's always some tricky ones that come up, so I like to show you one that might not be so straightforward. So for example, we have x squared minus 4x plus 4. We'll pretend we have an equal sign, so it will equal 0. And the factors of 4 that up to -4 would be 2 and 2, so x minus 2 and x minus 2. So we only get one breaking point of x equaling 2. So here we have 0, 1, 2, -1, -2, and then 3. We only have a 1 breaking point. So we just have a left side and a right side. So if we do a test point of x equaling 0, plugging that into the original, we get 0 squared minus 4 times 0 plus 4 is supposed to be less than 0. So we end up with 4 is less than 0, which is false. So this side would be a no. But let's try a point over on the right side. So again, if we do a test point of x equaling 3, plugging that in, we get 3 squared, which is 9, minus 4 times 3, which is 12, plus 4 is supposed to be less than 0. Well, 9 minus 12 is -3, -3 plus 4 is 1, and 1 is not less than 0. So this is a no. So the left side was a no, and the right side is a no. So therefore, sometimes you might end up with infinitely many solutions. It just all depends. In the next video, we'll talk about the rational inequalities.